Okay, so looking at what we have on page 41 and we have with number 87. Okay, we are looking at factoring, and in this case we have the trinomial expression 7y cubed z minus 440y squared z squared minus 12yz cubed. And now just looking at factoring. Okay, so common factors that we have here are going to be y and z. So if I start out factoring out yz, so we have left over. Okay, so we have yz into the trinomial. We have 7y squared minus 40yz minus 12z squared. Now this expression can be factored even further. And going back to what we have in the case factoring by grouping. Okay, so just factoring this portion out. And just in a manner of speaking, stepping over to the side. Okay, so you have 7y squared minus 40yz minus 12z squared. And as we look into factoring by grouping, okay, so again we have with the leading and the last coefficients. So we have 7 and negative 12, and taking the product, okay, we have negative 84. And again, we want to turn around and determine factors of negative 84 that will add up to minus 40. And of course, 7 and negative 12 will not be that combination. And in the case of attaining factors of negative 84, that will add up to negative 40. So more weight is going to be given to the negative factor than to the positive. Okay, so for these numbers, we will have negative 42 and positive 2. Again, these factors will add up to negative 40. And so in taking what we have with negative 42 and 2, so we can split up the yz term that is in the middle. And just setting up, okay, the factoring by grouping. So right now we have 7y squared. And if you have a negative and a positive factor, I would recommend just put in the negative term at the front. So we have negative 42yz, and we have plus 2yz minus 12z squared. And in looking at crossing over to factoring by grouping, again we have with the first pair, we have 7y squared minus 42yz, and we have for the middle operation, okay, we have addition. So we're going to have the quantity of 2yz minus 12z squared and so looking at drawing out, okay, the greatest common factors. So we have for 7y squared minus 42yz, greatest common factor is going to be at 7y. As for 2yz minus 12z squared, greatest common factor, okay, we have even numbers, so you have 2 and z. And 7y into the first binomial, we're going to have y minus 6z. And 2z into 2yz minus 12z squared. Okay, we're also going to have y minus 6z. And so we have for the factors. So you have y minus 6z. And then you're going to have times the quantity of the outside terms. So we have 7y plus 2z. Okay. And again, this is part of the solution to what we have overall. So going back to what we have in the initial setup, Okay, so for the original problem, we had this trinomial and we factored out yz. So we have, again, the first factor we have at yz. And for the rest of the solution, we have the binomial factors we just attained. So we have, in terms of the complete factorization, we have yz times the quantity of y minus 6z times the quantity of 7y plus 2z. And that would be the final answer in this problem. In the case of what we have regarding number 91, and we have in this problem, so we have 50x cubed plus 160 x squared y plus 128 xy squared. Now if you notice, okay, out of all the terms we have even coefficients as well as the letter x, and the greatest common factor that we have, okay, is going to be at 2x, and factoring out 2x, now we have 25x squared plus 80xy plus 64y squared and we're going to be looking at factoring even further. And so just looking at what we have with the trinomial, and factoring this particular portion, so looking at factoring by grouping, so we got leading coefficient, again it's going to be at 25. Last coefficient we're going to have at 64. 25 times 64 is going to be at 1600. Now we want to attain factors of 1600 that will add up to 80. Now it turns out that 1600 is a perfect square number. And for this value, now we got 40 times 40 is going to be 1600, and simultaneously 40 plus 40 will be 80. So using these coefficients, okay, so we're going to split up the 80xy into two terms that are identical, where we have 40xy. So we have, in the case of following through, okay, so we have 25x squared plus 40xy plus 40xy plus 64y squared. And looking at factoring by grouping, okay, so if I group into pairs, okay, we have for the first two terms, so I have 25x squared plus 40xy. For the middle operation, okay, we have addition, okay, and then we have in quantifying, so we have 40xy plus 64y squared and drawing out once again the greatest common factors. So we have with 25x squared plus 40xy, greatest common factor here is going to be at 5x. And for 40xy and 64y squared, okay, this part is going to be 8y. And in terms of factoring, say 5x into 25x squared, we have 5x into 40xy. So you have 8xy, 8y into 40xy plus 64y squared. Very same thing here. We have 5x plus 8y. And so we have, in the case of the factorization of the trinomial, you notice we have 5x plus 8y, and you have times the quantity of the outside terms, which will also be 5x plus 8y. So we have a repeat of linear factors, and we can put this in condensed terms as 5x plus 8y quantity squared. And so just going back to what we have in the original problem. Okay, so the first factor we pulled out was 2x, and for the completion of the factorization, and we have from our trinomial, again we have 5x plus 8y quantity squared. So we have for 2x times the square of the binomial 5x plus 8y. That would be the final answer to what we have in problem 91.